ungrouped frequency distribution. So ungrouped frequency distribution means it's a distribution, but the values of the variable are individual values. They are not grouped as a class intervals, right? That means now number of customers coming to the bank, not number of customers. For Monday, how many customers came to the bank? For Tuesday, how many customers? For Thursday, how many customers? Such kind of informations, right? Over a 1 month, right? How long they are coming, right? So if there are individual values, if we are organizing as a variable values and the corresponding frequencies, then that is called as a ungrouped frequency distribution. Then for a grouped frequency distribution, we are organizing a frequency table with the class intervals, right? So if these kind of data are summarized in the frequency table, then how we can calculate the measures of central tendency? So here, what is an ungrouped frequency distribution means? It shows the frequency of an item in each separate data value rather than groups of data values, right? So the variable values or data values are individual values, not a class interval, group of values, right? So for this ungrouped frequency distribution, this is the summary of calculations of the 3 measures of central tendency. Right? For mean, how we are organizing, x bar equals summation of fi xi over summation of fi. So here fi is a frequency of the ith data value. Here x is a data value and fi is a number. How many times this xi observed? Right? For ungrouped, actually, there is no this frequency term. Right? Summation of xi over summation of fi. But for the ungrouped frequency distribution, each and every xi should be multiplied by the corresponding frequency. So frequency, how many times occurred the particular value, divided by n. Here n is calculated by adding all the frequencies. That is summation of f of I. Then median, as usual, how we did for the raw data, it is a midpoint of the ranked values. So you have to identify the position n plus 1 by 2. So here actually we will use the cumulative frequency to identify the appropriate position of the median. Then based on that position, we can identify the appropriate data. Then mode, as it is in the raw data, most frequently observed value. So in this case, for a frequency distribution, the highest frequency, the data value which has the highest frequency, right? So now we will take a simple example. So here we are taking an example. It is a computer shops. It sells a desktop computer system, and we are observing a month, 30 days, compute the measures of central tendency, and then we have to interpret them. Right? So this is the data for this example. Now here we are taking desktop sold. For 1 month we are observing. So only out of 30 days, right? 0 computer sold only for 1 day, and 1 computer sold only for 2 days, 2 computers sold for 10 days, 3 computers sold for 12 days, 4 computers sold for 5 days, right? Now from this table, what is the variable? Identify the variable and put in the chat box. what is the variable? Number of desktop computers, what? Sold, right? Number of desktop computers sold. That is the full description of your variable, right? It is not a complete description of the variable, right? So, but number of computers sold. Clearly, you have to write it. Then, which one shows the frequencies? In this table, what is the frequencies? The number of days is a frequency, right? Don't confuse it, right? This is a number of days, right? This is the number of computers sold. So here we want to find out number of desktop computer system it sells over a month. So compute the measure of central tendency and interpret them. Then only you have to identify, right? Which one is the variable xi values, which one is the frequency values. So now we want to find out the measures of central tendency. So if you want to interpret them, then clearly we have to know that what will be the variable and what will be the frequency. So here the frequencies are how many times occurred a zero computer sold. That is one time, right? So 10 days, the 2 computers were sold. 12 days, 3 computers were sold. So these are the frequencies and these are the variable values. So here it is a ungrouped frequency distribution, right? So here now, according to the table, here already I calculated all those things, right? So here today we have to move very fast. Today we have to complete this one because we are lacking very far from the schedule or planning lectures. So that's why here I calculated, and you look at this one, then you have to read it and you have to do yourself without looking this exam, without looking these answers, right? So that is the way of practicing. So we are first we are looking at the mean number of desktop computer system sold in a day by Bits and Bytes shop, right? So now you look at how we are writing, now for which we are calculating the mean. So if you know that one, then only you can able to interpret. So if you want to interpret clearly, then we have to know that for which we are calculating the mean. So to identify for which we are calculating the mean, the variable you have to define clearly. So now here we are looking at the mean number of desktop computer system sold for a day, right? So that is, this is an ungrouped frequency distribution table. So the mean is calculated by x bar, that is summation of fi xi over summation of fi. So when we have to create a column fi into xi. So this is xi, this is fi. So 0 into 1, 0, 1 into 2, 2, 2 into 10, 20, 3 into 12, 36, 4 into 5, 20. Then when we are adding the frequency column, then you will get summation of fi. And when we are adding all the terms in Fi into Xi column, then you will get the total number of computers solved. So out of 30 days, 78 computers solved, right? So Fi into Xi means the total number of computers solved. That is the meaning of this one. Why? Because 0 computers solved only 1 day. So that is 0. But 1 computer solved 2 days. So these 2 days, 2 into 1, out of 2 days, 2 computers solved. So in the 10 days, 20 computers solved. Likewise, when we are multiplying this one, then you can calculate the total number. So 78 over 30, that is 2.6. Right? So now already how we made the interpretation for the ungrouped data. Similarly, here also you can make the interpretation. The similar pattern, you can follow it, right? So before making the interpretation, you look at those interpretations for how we did for the ungrouped data. Similarly, you have to apply for the ungrouped frequency distribution. So on average, 3 number of desktop computer systems solved in a day by bits and bytes shop. On average, 3 number of desktop computer systems solved in a day by bits and bytes shop. Right? So to calculate the median for what is the median number of desktop computer systems solved in a day by bits and bytes? First, we have to look at the position for the ordered data. So here, this frequency table shows the ordered data, right? They are in the ranking. This is the ranking values. So in such ranking values, they are ordered in the frequency distribution format, right? So 0, then it is a 0, then 1, 1, then 2 occurs 10 times, 2, 2, 2, 2, 10 times, then 3 occurs 12 times, then 4 occurs 5 times. So 30 plus 1, the position value of n plus 1 divided by 2th position of ordered data. So that is 31.2, 15.5 position. 15.5th position. So now here we have to look at where the 15th position occurred. Right? So to this one, we have to identify the cumulative frequency. So here, how already we learned how we can calculate the cumulative frequency. It is 1. Then for it is 3. 1 plus 2, 3. Then 10 plus 3, 13. Then 12 plus 13, 25. Then 5 plus 25, 30. Right? So that means here 3 here third, this is the 3 total number of 3 frequencies. Here 3 computers solved, that is below 0 and 1. It is 13 computers, 2 and below 2. It is a 25 computers, 3 and below 3. So 15.5 position, here 13, up to 13 computers here. So 15.5 fifth position is coming under this class, under this cumulative frequency. So 15.5, 13, then from 14 to 25 computers are here. So 15.5th position is there. So in corresponding this position, the number of computers solved is 3. So the median number of computers solved is 3 computers. Right? The median number of computers solved is 3. So what is the interpretation of this one? 50% of the number of computers, right? 50% of the computers solved 50% of the number of computers solved are 3 or below 3, right? 50% of the 50% number of computers solved, right? Or 50% of desktop computer system solved is 3 or below 3, and 50% of the number of computers solved is 3 or above 3. Right? How we interpret in the raw data. Similarly, here also you have to interpret it. Then mode. It is the highest frequency. For which data the highest frequency occurred. So here you have to look at the frequency column. Right? So here it is also out of here only 1 time. It is 2 times. It is 10 times. It is 12 times. It is 5 times. So 12 times 3 number of computers solved. So this is the highest frequency occurred. So the mode number is 3. So the highest number of the most occurring number of computers, the most frequently occurring number of desktop computer system solved is 3. Right? So similarly, after calculating all those figures, then you have to know that how we can interpret them. Right? Now, we are going to calculate the measures of central tendency for the frequency distribution. It is a group data. So, we have to calculate the measures of central tendency for grouped frequency distribution. Right? So, when data are grouped, such as in a frequency table or histogram, we can estimate the mean, median, and mode by using the following formulas. Right? So here actually, there are a lot of values in a particular class interval. Right? So how we can identify because when we are calculating the mean, the xi values, we have to know that. Right? So here for one particular class interval, there may be several observations. So how we can identify those observations? So here we are going to approximate all those values by a particular midpoint of the class. Right? So here this is the main point. How we are calculating the measures of central tendency for a group data. So here in the previous case, we know the xi values. These are the xi values. But for a grouped frequency, the xi values are we couldn't identify each and every xi value. We couldn't identify because the particular some values of individual xi's are put in the group. So each and every value in the particular interval we cannot identify when we are having a frequency table. So how for these xi values we are going to take? For rather than taking the class interval, we are assuming that all of the values are approximately equal to the midpoint of the class interval. All of the values are approximately equal to the midpoint of the class interval. So that's why we are saying that the mean and the median and the mode are approximated value. For a grouped frequency distribution, the calculated measures of central tendency are approximated values. But for the ungrouped frequency distribution and the raw data, we can calculate the exact values. But only for the grouped frequency distribution, we can calculate the approximated measures of central tendency. Why those measures are called approximated values? Because each and every value in the class interval is approximated by the midpoint of a particular class interval. Right? This is the sentence. All data values in a given class are treated as though each of them equals the midpoint x of the class. Right. So, in this case, how we are calculating x bar, the same formula what we used for the ungrouped frequency distribution. Here also the same formula, but xi is the midpoint of the ith class, right? And n is a summation of fi, that is the total number of frequencies, and fi is the number of values, frequency in the ith class, right? And similarly, the median, the approximating the median from a frequency distribution, how we can calculate the median. This is the formula here we are using. Median is for a grouped frequency distribution table. Median is equal to L plus n by 2, that is summation of fi, total frequency divided by 2, minus, this is the cumulative frequency preceding the median class. M is the cumulative frequency preceding the median class. And F is the frequency of the median class. And C is the class width of the median class. And L is the lower limit of the median class. So here, if it is the lower limit, or sometimes we have to use the lower boundary of the median class. Suppose, for example, in our frequency, grouped frequency table, if the class intervals are organized, and suppose, for example, first interval is 5 to 9, and the second interval is 10 to 14, 5 to 9 and 10 to 14, then there is a gap between the upper limit of the previous class and the lower limit of the present class interval. There is a gap, right? 5 to 9 and 10 to 14. So there is a gap. In the gap, then we have to take the boundary. Already we learned that how we can identify the boundaries, right? So if the 5 to 9, then 9.5, and 10, then the lower limit will be 9.5. In that case, that is the boundary. If 5 to 10 and 10 to 15, then lower limit. Both the boundaries and the limits are same, right? So when we are writing this median, defining this median for a grouped frequency distribution table, by writing this formula, and also you have to know that what those terms representing, right? If you know perfectly all those terms, then only you can calculate correct. What the previous batch students are doing, they are memorizing the formula, but when they are calculating the median, they don't know what those terms are, right? So this is the case how they are only studying before the exams. Just they are looking at the formulas, and there's something before the previous, or the 2 days before the exams, they are just reading. Then they don't know what those terms are mentioning. So when you are practicing, when you are learning about this median for each and every type of distribution, you have to know that how we can calculate those medians and how we are defining those terms. Each and every term you have to know that. So L is lower limit or lower boundary of the median class. N is the total number of observations, that is given by summation of F. And M is the cumulative frequency preceding the median class. And F is the frequency of the median class. And C is the class width of the median class. So here, after put this formula, first you have to identify the median class. If you identify the median class, then only you can calculate all those terms. So how we can identify the median class? Similarly, n by 2 or n plus 1 by 2. Because when the number of observations are very large, actually n by 2 is, we can use the n by 2 term to calculate the position of the median. From that, you can identify the median class, right? Then similarly, what is the approximated formula for mode? it is mod is equal to L plus D1 divided by D1 plus D2 into C. Here L is the lower limit or lower boundary of the model class. Then D1 is the difference between the frequencies, two class intervals, and D2 also frequency of the two class intervals. Now how we are identifying? To calculate the D1, we know F1 and F node. So F1 is the frequency of the model class. F node, frequency preceding the model class, right? And F2, frequency succeeding the model class. So if you are taking F1 is the model class frequency, then F node, the frequency of the class interval that is just before the model class, node 1, right? Then D2, F1 minus F2. You look at D1, here F1, that is preceding the model class, the frequency that just before the model class. Then D2, F1 minus F2. F1 is the model class frequency, F2 is the class interval that's succeeding or the following class interval, model interval frequency just following the model class. And C is the class width of the model class. So here also you have to identify the model class. So how you can identify the model class? That has the highest frequency. Which class interval has the highest frequency? That will be the model class. So now we'll look at the example. This is the a consumer advocacy group tested a sample of particular type of battery and recorded the lifetime in the nearest hours. The data set is given below. Right. Now, again, you read this example. Here the lifetime, which are organizing in the class intervals form. So, the lifetime, if a 0 to within 50 hours, this is the number of batteries, 6. Then lifetimes are in between 50 to 100. 21 number of batteries has lifetime in between 50 to 100 hours. 20 number of batteries has lifetime in between 100 to 150 hours. 9 batteries have lifetimes in between 150 to 200. Similarly, the lifetime of hours and the corresponding number of batteries have organized in this table, right? First, you have to put your answers in the chat box. First, describe the population. What is the population and the sample and the variable? Put in the chat box. This kind of a revision for your chapter 1. The first question is coming from the knowledge you gain from chapter 1. According to the given statement, only you have to define your population, only what are the information available. Using those information, you have to define your population and your sample. First, you identify the population and sample. What is for to identify, first you have to think about the definition of population. What is a population? A particular type of all batteries. Very good. And the sample is a 60 batteries. Right? The 60 batteries selected. Sample is the selected 60 batteries by the consumer advocacy group. That is more suitable, right? Population, a particular type of all batteries, right? According to this example. And the sample, the selected 60 batteries by the consumer advocacy group for testing the lifetime. Right. Okay. Right. Now define the variable. What is the variable under study? So to define the variable, you have to think about what is the definition of variable. Variable is a attribute that describes the attribute of the item. That describe the attribute of the items. So here you know that items are the batteries. So according to that, now you have to know which attributes we are looking at in the interested. What is the interested attribute over here? That will be the variable. So according to this definition, now identify your variable. Lifetime hours of the batteries. Very good. Lifetime hours of the batteries. This is the, according to this example, this is the variable, right? Lifetime hours of batteries, right? Who are the students? They are not get the answers. You can take these as the answers, right? Okay. Now it is a grouped frequency distribution. Now we have to find the mean, median, and the mode. Lifespan of the batteries. Lifespan means lifetime, right? How long they are surviving. Oh, the usage, how long or how many hours the batteries are used. That is the lifespan of the batteries. Right. Now, according to this one, we have to prepare a table, right? To calculate the mean and the median and the mode. This type of table is important, right? Now here finally we look at this one. The 0 to 50, 50 to 100, 150 to 150, 150 to 200, 200 to 250. The number of batteries is a frequency. This is your variable X, right? This is your variable X. So number of batteries F5, that is 6, 21, 29, 4. Now here 6 means 6 batteries, right? Have their lifetimes in between 0 to 50. Here means 21 batteries have their lifetimes as 50 to 100. Similarly, there are total number of batteries 60. That is summation of Fi. Then here you know that how we are going to take the Xi value. We don't know the individual values for there are 6 batteries. So each and every battery have a lifetime in between 0 to 50, but we don't know what will be the exact. For the first battery, what is the lifetime? For the second battery, what is the lifetime? We don't know that information. Right? So now, for that one, now we have to take the midpoint. So what is the assumptions we make? That the 6 lifetimes of this, the 6 batteries lifetimes are approximately equal to, what is the midpoint? 0 to 50, 25 hours. The lifetime of these 6 batteries are approximately equal to 25 hours. Right? In this case, similarly, the midpoint is 100 plus 50, 75. So this 75 hours means 21 batteries lifetimes are approximately equals 75 hours. Here this means 20 number of batteries lifetimes are approximately equal to 125 hours. So 9 batteries lifetimes are approximately equal to 175 hours. 4 batteries lifetimes are equal to 225 hours. Right. So according to our x bar, that is summation of Fi xi over summation of Fi. Here this gives the total lifetime hours. This gives the total lifetime hours. So how we can get the total lifetime hours? So 6 batteries has 25 hours. So from this 150 lifetime hours. But 21 batteries have 75 hours. So total lifetime hours, this one, 1575. Similarly, the Fi xi, an addition of all these values give the total number of lifetime hours. So now we have to get the 1 battery, lifetime hour for 1 battery. So we considered 60 batteries. So here we have the total lifetime hours divided by 60. That is 111.67 hours. So for a 1 battery lifetime is 111.67 hours. So this column is created based on this table. Right? So this is the method of calculating the average lifetime or mean lifetime for the batteries, which are organized by a grouped frequency distribution table. So this is not an exact, this is the approximated mean time. Why it is approximated? Because here each and every lifetime is approximated by the corresponding midpoint of the grouped class interval. Right? So how you can interpret this one? On average, the lifetime of a particular battery, on average, the lifetime of a particular battery is approximately 111.67 hours. Here, it is better to have a word, the approximately. Right? On average, only the same type of interpretation, only you have to add the word approximately. Right? On average, the lifespan of a battery, on average, the lifespan of a particular battery is approximately equals 111.67 hours. Right. Now we are going to ready to calculate the median. So first, you have to identify the median class. Right? What will be the median class? So to identify the median class, we have to get the position of the median. We have to get the position of the median. So already the position of the median, we learned how we can get the position of the median. That is because here the number of observations are larger than 30. So we can use n by 2. Or you can, there is no harm of using n plus 1 by 2 also, you can use it. That is no harm, right? So here actually I am using the n by 2 positions in the ordered data set. This is the definition of identifying the position of the median, not the median, position of the median. Right? Median is in this position, n by 2th position in the ordered data set. So value of the n by 2 nth position of the order. So that is total number of frequencies 60. That is 30th positions in the data set. Median will be the value of the 30th position in the data set. So how we can identify the 30th position? We have to use the cumulative frequency. So we are calculating the cumulative frequency for the first class interval 6. Then for the second class interval 21 plus 6, that is 27. Then third class interval 20 plus 27, that is 47. Then for the fourth class interval 9 plus 47, 56. And the last class interval 40 plus 56, 4 plus 56, 60. This will be the last class interval cumulative frequency will be the total frequency of the given distribution. So now the 30th position. So where will be the 30th position? Here up to 27 observations, right? So the 30th observation will fall here in the 47. Cumulative frequency 47. So here the 30th observations will be there. So the 30th observation is here, that the corresponding class intervals 100 to 150. So according to that, the median class is 100 to 150. Right. Now after identifying the median class interval, according to our defined formula, now we have to identify the proper terms. Right. So this will be the median class interval, right? According to the previous case, the median class interval we identify. So the median class is 100 to 150. Now you can apply the formula. So the formula is given by median is equal to L plus n by 2 minus Cf divided by median class interval frequency. What is L? L is the lower limit over lower boundary. So here actually, this is 50, this is 50. Both are same. There is no gap between the upper limit of the first class interval and the lower limit of the following class interval. There is no gap. 50, 50, 100, 100, 150, 150, 200, 200. So the lower limit and the lower boundary are same here. So L is 100. N by 2, total number of frequency divided by 2, that is 60 by 2, 30. Minus, this is the cumulative frequency preceding the median class. So this is the median class, then preceding the median class or the previous class interval, that is 50 to 100. Then what is the corresponding cumulative frequency? 27. That is 27. Then this will be the median class interval frequency. So this is our median class interval. So this is the median class interval frequency 20. And C is the class width. So how we can identify the class width? By taking the lower limit of the two class intervals or upper limit of the two following class intervals. So 100 minus 50, that is 50, or 150 minus 100, that is 50. Simplifying this one, then you will get 107.5 hours. Right? So now we can, this is also approximated median, right? So what is now our interpretation? After calculating each and every measure, you have to know the interpretation. So how we can interpret it? So 50% of the battery's life, or 50% lifetime, 50% of the battery's lifetimes, right? 50% of the battery's lifetimes are approximately 107.5 hours or below 107.5 hours, and 50% of the battery's lifetimes are approximately 107.5 hours or above 107.5 hours. Right? Similarly, how we look at the ungrouped frequency distribution or raw data, similar pattern here also we have to apply, but only you have to take the term approximately. Right? Right. Approximately 50% of the batteries lifetimes are approximately equals 107.5 hours or below 107.5 hours. And the 50% of the battery's lifetimes are approximately equals 107.5 hours or above 107.5 hours, right? Okay. So this is the method of calculating the median. Right. Now we want to calculate the mode, lifespan of the batteries. Find the mean, median and mode. Now here we are completed mean, and also we explain what is mean, and median we calculated and we explain what is median. Now we want to calculate the mode. Right. Now what is the definition of mode? Mode is the value which frequently, the most frequently occurred value. Mode is the most frequently occurred value. So here we are looking at the mode. In this, 21 is the highest frequency. So according to that definition, if you want to apply for the grouped frequency table, then the highest, which data that most of the highest frequency occurred value, the data which has the highest frequency, the data which has the highest frequency. So here 21 is the highest frequency. So according to that, now here we can identify the model class, right? So the lifetimes which are in between 50 to 100 that occur 21 times. So this is the highest frequency. So according to that, model class is 50 to 100. So to calculate the mode lifespan of the batteries, first we have to identify the class interval which has the highest frequency, that is 50 to 100. This is the frequency column. Based on that one, we have to identify this one. Now the formula is M naught, that is L plus D1 over D1 plus D2 into C. Now, according to that one, L is the lower limit or lower boundary. Here both are same of the model class. So that is 50. Plus D1 is a F1 minus F naught. F1 is the model class frequency, that is 21. And F naught is the frequency of the class preceding the model class, that is 6. 21 minus 6. Then D1 again this one plus D2. D2 is the difference between the two following class intervals frequencies. So that is model class frequency is 21 and the class interval frequency which following the model class, that is 100 to 150, 20. So 21 minus 20 into class width of the model class. So how we can identify? By taking to this one, lower limit of the difference between the lower limits of the two class intervals, succeeding or preceding class intervals, 50 minus 0, that is 50. Right? So for model class frequency, we have to calculate the preceding class, subtract the preceding class intervals and the following class interval frequencies. So this formula you have to memorize. So from that, that is 96.875 hours. So now if we are taking the interpretation, right? The most frequently occurring lifetimes of a battery, the most frequently occurring lifetime of a battery equals approximately 96.875 hours. The most frequently occurring lifetime The most frequently occurring lifetime of a battery approximately equals 96.875 hours. Right? Now we completed part A, B, and C. Right. Draw an appropriate graphical representation for the data. Right. Now you put your answer, which graph you will take to represent this frequency data summarized by this frequency table. Put your answer in the chat box. What will be the appropriate graphical device to present those data summarized in the frequency table? Put your answer in the chat box. This is a knowledge you gain from chapter 2. You have to apply your knowledge you gain from chapter 2. So to identify the appropriate graph, here you have to look at the variable, whether it is a discrete variable or continuous variable, and what is the level of measurement. Mainly, you have to look at the level of measurement for this variable, and accordingly, you can select the appropriate graphical device. Is it continuous or discrete, and what is the level of measurement? Based on that one, you can select the appropriate graph. Put the level of measurement and the appropriate graph in the chat box. First, you put the level of measurement in the chat box. What is the level of measurement? Already you identified the variable. Variable is a lifetime of a battery. Right? They are measured in the hours. So accordingly, whether it is a quantitative or qualitative, first decide. Then whether it is a continuous or discrete. According to that, then you decide it whether it is a what will be the level of measurement. Put in the chat box. There are 4 levels of measurement. Right? Accordingly, select the appropriate level of measurement. First, you put in the level of measurement. Right. It is a ratio, lifetime hours of batteries. So here it is a quantitative variable. Right? And the continuous variable, it will take the decimal points also. So measurable and take the decimal points, so continuous. And 0 is also possible. True 0 is there. So it is a ratio. Then, if it is a continuous variable with a ratio level of measurement, what is the appropriate chart we learned? there are mainly three types of chart we learn: pie chart, bar chart, histogram. Right? So now I give a clue. You learn the pie chart, bar chart, histogram. Here, which is the appropriate? Very good. Now only you are able to get the idea. Right? So the chapter 2 is not thorough. If you know the chapter 2 clearly, then only you can find the appropriate graph here. It is a histogram, right? Because it is a continuous data. So only the most appropriate diagram for a continuous with a ratio level of data, the histogram. Right? So I leave this part as a homework, because already you take chapter 2 and identify how we can draw the histogram. Right? Accordingly, you draw the graph. And from that graph, you have to interpret, you have to take the two insights from the graph. One is the shape of the distribution, and other one is how they are scattered. Mainly the shape of the histogram. Whether it is a bell-shaped or whether it is a skewed. If it is a skewed, it is a right tail or the left tail. And also, you have to compare the mean, median, and the mode. From that also, you have to describe the shape of the distribution. These two parts I am leaving as your homework, right? So already we learned in the previous chapter, mean, median, mode comparison. I think for the ungrouped data we did, and already in the some of the last slides also we will do it, comparing the mean, median, and the mode to identify the shape of the distribution. Right? So now histogram, you have to get the insight. What is the shape of the histogram? Data distribution. Lifespans times shape of the distribution of the lifespan times. These are the homework, right? Okay. So now you will, how we are connecting with this. This is a complete like a exam type question, right? We are starting with the first chapter and then move to the calculation frequency table, second chapters, understanding, and also the third chapter. So all these three chapters are connected in the one question, right? Here also, here you have to include the word approximately, right? Here also these interpretations are here. And the graphical representation, I am leaving it as a homework. Right. Now, another important topic, variation. Right. Now here you look at in this data, there are each and the lifetimes of, suppose we are considering the lifetimes of the batteries. The lifetimes of the batteries are now ranging from 0 to 250, right? 0 to 250. Now, this 0 to 250, we summarized by, there are 60 batteries lifetimes. They have the different values, 0 to 250. Some of the values are same, some of the values are different. But they are ranging from 0 to 250 hours. Now, these 60 lifetimes, we summarized by a one of the figure as a mean 111.67, as a median 107.5, as a mode 96.875. So, if we are taking as a mean as a summary measure, then the 60 lifetimes hours are summarized by this one figure. And this, if we are taking the median, then the 60 lifetime hours, 60 batteries lifetime hours are summarized by this one figure. So now these 60 observations are summarized by a one figure. So when we are summarizing this one figure, we have to also include the additional figure how the battery's lifetimes are variated from this summary measures. How these lifetimes batteries are deviated from this mean or from this median or from this mode. These variations must be given. Then only we have to know that the lifetimes batteries, how they are distributed. Just if we are giving 111.67 and we don't know whether they are very close to this mean value, all the battery lifetimes are very close to mean values, or all the batteries lifetimes are very far away from this mean value. If some of the what call extreme points, outliers are there, then we couldn't identify whether these are having some outliers or all are very close to the central point. This kind of information we have to know that. So just when we are giving this measures of central tendency, in addition to that one, we have to give how the battery lifetimes are deviated from the measures of central value. That is called as a variation, right? So what is the meaning of variation? The variation is the amount of dispersion or scattering of values away from a central value. The variation is the amount of dispersion or scattering of values away from a central value. Now we look at, there are two different distributions, but both distribution have a same measures of central tendency, right? This is the measure of central tendency. Almost it is a mean. This mean is given by, for this distribution is given by this one, both distributions. But we look at, there are different variations, right? So one is from, first this data has from this one to this one range, but this data has a range from this to this. So same center, different variation. So definitely when we are summarize our data with a mean value or median value or mode value, then we have to give the how the variation measure also we have to give. This variation measure tells about the amount of dispersion, or to what extent they are scattered from the central value. To what extent the data value are scattered from the centered value. This is the meaning of variation, right? Right. Here also several measures we have to measure the variation. Range, that is one of the measure, easiest measure. Then variance and the standard deviation and the coefficient of variation. These three measures are interrelated. Variance, standard deviation and the coefficient of variations are interrelated. They are related to the mean value. Measure of central tendency, we are taking the mean value, right? First, we are looking at the range. The range is the very simplest measure of the variance or variation. It is the difference between the largest and the smallest value. Already we learned, where we learned the range. Already you learned how we can calculate the range. In the which chapter you learned the range? Can you remember? Put in the chat box. Already we learned this measure of calculating the range. To what purpose we use this range? In chapter 2, we learned this one. For what purpose? For what purpose? To find the class width. Very good. To find the class width, we applied this definition range, right? Okay. So range is the largest value minus smallest value. Now here you look at, this is the data. Only range is 14 minus 1, 13 units. The data are ranged within the 13 units of the data, 1 to 14. 14 minus 14 is the largest observation. 1 is the smallest observation. So 14 minus 1, 30. Within that, all the data are distributed. Right? Now here we look at what is the disadvantages of using the range. Here range is 12 minus 7, 5. Here also range is 12 minus 7, 5. So here we couldn't identify. Both range are same, but the distribution pattern is different. Here equally each and every value is distributed, but here most of the data are distributed around 10, 11, 12. Most of the data are around 10, 11, 12. So now here you look at, but only if the range is 5, we couldn't identify how the data are distributed. So one of the disadvantages is it's ignoring the way in which the data are distributed. That means we couldn't identify how the data is distributed if we are just using the range. Both are equal range, but here the distribution is entirely different. Here equally distributed, but here most of the data are distributed towards the right-hand side, tail side of the data, right? And also it is very sensitive to the outliers. Now you look at, for ranges, it is 1, 5 minus 1, 4, right? So most of the data between range from 1 to 5. But here, if you're looking at this one, range is 119, but only because of the one observation. Other data are ranging from 1 to 4, but the last observation, it is an extreme value, 120. Because of that, the range is 119. So now we look at, if the data is unknown, then we know that. We don't know how the data values are distributed. Because of one extreme point, the range is very large. Otherwise, the range is very small. Right? So these two are the disadvantages of calculating the range. Right? And also, how we can properly measure the variation. We are going to use the variance and the standard deviation. Right? Variance and the standard deviation. This is another kind of measures of variation that is commonly used. Variation is related to the mean value. Right. Now, here we are looking at, already we know that this data set has the small variations comparing to this data set. Right? So then we can say that it is a small standard deviation and this data has a large standard deviation using based on this range. Right? So now what is the standard deviation? It measures how this is the mean value. Right? If it is a symmetrical bell-shaped with a one mode, then we know that mean, median, mode are same. Already in the graph, we learned that, right? Chapter 2. So, how each and every value are deviated from the mean. If all the values are very close to mean, then these deviations are very small. If some of the values are deviated from the mean value far away, then this standard, the deviations from the mean also will be very large. That principle here we are going to use to calculate the standard deviation and the variance. Here actually, this is for the raw data. we are calculating the variance for the row data, right? Now here we are taking the sample variance. So what is variance? Variance is all the variance measures, even in the row data or in the group data, that is approximately measure. Variance is approximately measure, right? Average of squared deviations of values from the mean. What is the variance? That is the average. Now you look at the terms of squared deviations of values from the mean. Right now, this is the formula. Squared deviations of the values. First, you look at this term, deviations of the values from the mean. Look at this part, right? Deviations of the values from the mean. Our values are xi, mean is x bar. So, xi minus x bar. This is the deviation of values from the mean. Then, look at the term squared. So, we have to square these deviations. First, you have to find the deviations of the values from the mean. Then, you have to square for each and every value. Xi, first observation, x1 minus x bar. Second observation, x2 minus x bar. So, squared deviations of the values from the mean. Then, we have to get the average. That is approximately. That is, so we have to sum all the squared deviations, then divided by how many terms we considered. Right? So particularly for the sample variance, we have to divide by n minus 1 because of the biased property of the estimators. That is, you will learn in chapter 5 or 6 when we are learning the inference part. Then we will learn the unbiased estimator. When we are estimating the population parameters using the sample information, that should be the unbiased. Right? So, because of that property, for the sample variance, we are dividing by n minus 1. Because of that, we say that it is an approximated average. Right? Because we didn't divide by n. We are dividing by n minus 1. So, this is the approximated average of the squared deviations of the values from the mean. This is the definition of the variance. So, according to this definition, the variance is calculated by this formula. The sample variance is denoted by S squared. Sample variance is denoted by S squared. That is summation of I is equal to 1 to n. Xi minus x bar holding squared over n minus 1. So, x bar is mean, n is the sample size, that is the total number of observations. Then xi is the ith value of the variable x. Then when you are manipulating this formula, we will get the sample variance S squared is 1 over n minus 1. That is equal to summation of xi squared minus n x bar squared. Summation of xi squared minus n into x bar squared. This is the formula. This is the easiest formula to calculate the variance, because now if we are taking, suppose that y here, this is the exact definition. From this definition, we derive this formula. So why we use this formula as a computational formula? Because when x bar is a decimal point, if x bar is an integer, there is no problem of calculating this one, xi minus x bar squared. But x bar is an integer, the decimal, then when you are multiplying, squaring this deviation, then you will get, if it's we have a 2 decimal in the mean value, then when we are squaring, it will get the 4 decimals. Then it's actually, you take the time consumption and also you have a very large numbers with the decimal points. So it will take time consumptions. To avoid such kind of irritations, then you can use this formula. 1 over n minus 1, that is summation of xi squared minus only this one, only you have to add n into x bar squared. X bar already we calculate mean value. So by applying this formula, easily you can get the some variance, right? So don't forget, if you want to calculate the sample variance to get the average of the squared deviations, that should be divided by n minus 1. Then now we are coming with the standard deviation. First we look at the variance. It is a variance that is denoted by s squared. Then standard deviation. The standard deviation is most commonly used of measure of variation, right? It shows the variation about the mean, right, from the mean. It is the square root of the variance. So the sample standard deviation, you have to get the square root of the variance. This is the variance, right? So by taking the square root, then you can get the variance. And as the y here, we are taking the standard deviation instead of variance, because the measurement of the mean units, not the measurement scale, units of the mean and the standard deviation will same. Now when we are looking at the variance, here suppose you are now the lifetime we measure with the hour. Lifetime we measure with the hour. When we are calculating the variance, here we are squaring. So the units also squared, hour squared. If we are measuring the length by meter, then for the variance, the units is, mean is in the meter, right? But variance is in the unit of meter square. If we are measuring the liter, then mean is with the unit liter, but variance is with the unit liter square. So the interpretation part is little bit hard and also very difficult to understanding the interpretation. So to avoid such kind of thing, then we are calculating the standard deviations by taking the square root of the variance. Then if it is a meter square, then when we are taking the square root, then that will be the meter. Now the mean and the standard deviation has the same units, right? So has the same units as the original data. So now the interpretation with a mean we can interpret, and that interpretation is also very easy. For that purpose, when we are summarizing the data with a mean, in addition to discuss or talk about the scattered of the data from the mean, we are using the standard deviations rather than using the variance, right? So now we are calculating the sample standard deviations for the raw data. Now here actually we are taking the original definition of the standard deviation, that is S equal to summation of I is equal to 1 to n xi minus x bar holding square divided by n minus 1. And the mean is given by summation of xi minus summation of xi divided by n. So first we have to calculate the mean, because to calculate the standard deviation, we need the mean value. So first we have to calculate the mean. So these are the observations. So there are 8 observations. So n is equal to 8. Then x bar is equal to, add all these data divided by n, that is 16. Then standard deviation is 10 minus, first observation, 10 minus x bar. So 10 minus 16, you have to square, plus 12 minus 16 square, up to 24 minus 16 square. At all these squared deviations, then that should be, the sum should be divided by n minus 1. That is 8 minus 1. So that is 100 and square root of 130 divided by 7, 4.3095. So what this measure tells you, this is a measure of the on average, right? How you can interpret this one. On average, the data here, we have the data. We don't have any problem. The data are scattered around the mean by 4.3095 units. On average, the data, the given data are scattered around the mean by approximately 4.3095 units. Now we may solve. Most of the observations are scattered from the mean by 4.3095 from the mean. So 16 minus 4.35 and 16 plus 4.30. This is the interpretation of the standard deviation. Also, what is the notes I uploaded in your descriptive numerical measures? The clear interpretation is there for the standard deviation. So read it carefully, right? Now we are going to compare the standard deviations, where there are 3 different data sets are given here. They are distributed in the different manner, and we are looking at the standard deviation. Then how we can identify the distributions of this data, right? By applying those formulas. Now these are the calculated. So in the first case, mean is 15 and the standard deviation is 3.338. For the second case also, mean is same 15.5, but the standard deviation is 0.926. Compared to this one, it is very small. And the third data also, the mean is same, but the standard deviation is largest among these 3 data set. So now, if there is no standard deviation, just we are summarize with a mean by 15.5 for these 3 data set, then we couldn't identify anything. How these data values we couldn't identify, right? So it is very disadvantages of the mean. If we are summarizing all the observations just by the mean, but for 3 data set have the mean value of 15.5, but we couldn't know how these data are distributed, whether all these data are very close to mean or all these data are far away from the mean. That point we couldn't identify. Right. Now, looking at this diagram, 3 data sets and the distribution and these measures, now we tell which data set are very close to the mean value. Which data values are very close to the mean value, whether A, B, or C. Put your answer in the chat box. Put your chat box, your answer. Which data values are close to the mean value? They are approximately equal or very close to the mean values. For which data set? A, B, or C? Put in the chat box. Yes, B. Now here you look at B is very close to, by looking this diagram, all the observations, our mean values are 15.5. They are ranging from 14 to 17. So it is the central value. So all the data values are around the, scattered around the central value. So now you look at the standard deviation, that is very small, smallest value. So that indicates if the standard deviation is very small, then that indicates all the values are clustered around the mean value. They are very close to clustering around the mean value. The range is also very small, 14 to 17. Right. Now here you're looking at this data set. Right. Now here its ranging is 11 to 21. But mean is 15.5. Comparing to data set, what is the difference between data A and data C? The shape, data A and data C. In the data A, even most of the observations are, some of the observations are clustered around the mean value because 16, 17, 18. But some of the observations are far away from the mean value, 11 and 21. But scattered, comparing to the data set C, data A are scattered around the mean value, but not close to this data B, right? 3.38. So some of the data are far away from the mean value. The range is highest comparing to this one. But in the data set C, mean is 15.5. But because of these extreme points, the data are clustered or located around the endpoints of the data. 11, 12 and 19, 20. But the mean is 15.5. So here actually the mean value is not appropriate to summarize the data value. The mean value is not appropriate to summarize the data. Right? And also S is comparing to this data one. S is 4.56. This because of endpoints. Because most of the data are located in the lowest tail and the largest right tail and the left tail. So this is the perfect distribution, data B. Comparing to data A and C, data is best. Right? So this is the use of now we looked at how we can identify how the data are scattered. Even mean is same, but the distributions will be different. That difference we can identify using the standard deviation. Right? Right. Now here this data are given below are the times taken to get ready in the morning for 10 consecutive days. Already this example we looked in the calculating the measures of central tendency. So calculate the variance and standard deviations for getting ready times. It is a ungrouped data. It is a raw data, right? Time in minutes we observed for 10 days. Explain how the getting ready times data are clustered around the mean. Here I show the example. These are the X values. And we know we have to want the Xi squared. Now we are going to apply this formula. So here we need Xi squared. So first we have to calculate a summation of X bar. That is also we need this measure. That is 396 by adding this one divided by 10, 39.6. Then to apply, this is the definition of S squared. Then from this formula we derive as a computational formula as this one. Then N is 10 observations, 10 minus 1. Then summation of Xi squared, these values, minus 10 into X bar squared. That is already calculated, 39.6 holding squared. That is 45.82. That is the variance. Calculate the variance and the standard deviation for the getting ready times data. So the variance is 45.82. It is a hours squared. Variance is 45.82 hours squared. So this interpretation is actually a little hard. But actually, according to the definition, how we can interpret it, the on average or the average of the interpretation of variance, the average of squared deviations of the ready times, the average of the squared deviations of the getting times from the mean. The average of the squared deviations of the getting times from the mean of 45.82 is this amount, 45.82 hours squared. Right? Then standard deviation is S is equal to 6.77. Then the standard deviation is 6.77. Right? This is square root of the average deviations, square root of the average squared deviations from the mean of the getting times. But if we want to relate how they are clustered around the mean, the getting ready times are clustered around the mean, then we have to get the interpretation of standard deviation. Now you look at this standard deviation shows the getting ready times in this sample are clustering within 60.77. I think minutes, and 60.77 minutes around the mean of 39.6 minutes. This is the way of interpreting the standard deviation with the problem. The getting ready times in this sample are clustering within 6.77 minutes around the mean of 39.6 minutes. That is clustering between 39.6 minus 6.77, 32.83, and 39.6 plus 6.77, 46.37. So most of the values are in between 32.83 and 46.37. This is the method of interpreting the standard deviation. Right now, if you're looking at these observations, except few observations, the minimum 32.83 according to that, but only here 29 is one of the observation is below 29, and maximum is 46.37, 39, 52. 2 observations are out of the range, right? Only out of 10 observations, 2 observations are out of the range. All other data are within this 32.83 and 46.37. Right? So this is the interpretation of. Now you know that most of the observations are fall in between 32.83 and 46.63, and also it is approximately close to the mean values. So now when we are summarizing the mean value for the data, definitely you have to give the standard deviation also. Then only we know how all the original observations are, to what extent they are clustering around the mean. Okay, so we have to calculate the average scattered value from the mean to find the lower limit of the range, and we have to add the scattered average scattered value from the mean by the mean to identify the upper limit of the scattered value. Right? Right. What are the advantages of variance and standard deviation? Here actually each value in the data set is used in the calculation. Like a mean, each value are used in the calculation, and also values far from the mean are given extra weight because we are taking the deviations. So the mean is, we are squaring. So when we are squaring, that is a large value also we will get. Right? Then coefficient of variation. It measures the relative variation. In related to mean, what is the standard deviation? Actually, the coefficient of variation is related to mean. What is the standard deviation? Always we are expressing 1 minute. Right. Sorry for the disturbance. Right. So it always we are expressing with a percentage. It shows the variations relative to mean value. Now, when you look at the formula, in the formula you can identify coefficient of variation. It is a sample standard deviation divided by x bar. So for 1 unit of mean, how much of standard deviation is there? Right. This is the explanation of the coefficient of variation. So we are talking about the standard deviations relative to the mean value. So mainly where we are calculating this one coefficient of variations when we are comparing 2 or more sets of data set. If we want to compare the mean value and the variations among the 2 data sets, when they are measuring in the different units and with the different mean values. In these 2 cases, if we want to compare, if the sometimes data set different units. So according to that one, standard deviations is also for the some data set very low and for some data is very high. And if it is depending on the measurement units, then actually the comparison is not possible. Even though the mean value is also different, right? And because standard deviations are depending on the mean value. So that also the standard deviations will be, the extent of the standard deviations will be affected by the extent of the mean value. So in that cases, if the different mean values with a different measurement scales, then to compare these 2 data sets distributions, we have to look at the coefficient of variation. This is also another variation measurement, right? So now I am stopping this class at this point. Then tomorrow morning 6:30, we will meet it again, right? Any doubts if you want to ask? So tomorrow morning 6:30 again, we will meet, right? Okay. Thank you.